Hello students, welcome to another tutorial on projectiles. In this tutorial, we're going to look at a question where we have an object that is initially moving in the horizontal axis, and then it drops another object that is supposed to fall to the ground. Now, the concept here is very simple. It's something that we described earlier on. If you watched the introduction to projectiles, if you haven't, I'll leave a link to it in the description. But basically what is happening here is that we have a plane, according to the question. This plane has a horizontal speed or a horizontal velocity. So this velocity is in this direction, and we're being told that this velocity is of magnitude 90 meters per second. Now, with this, of course, my line might look something else, but let me try to make it more horizontal. Okay, so this plane is moving with a horizontal speed. Yeah, and then that speed is given as 90 meters per second. Now, this plane drops a parcel. Now, what you should keep in mind is that while the parcel was inside the plane, it was moving with the same velocity as the plane. So the minute the parcel is dropped in the vertical axis, since the plane was not moving in the vertical axis initially, what it means is that initially the velocity in the vertical axis was equal to 0, because the velocity of the plane and the parcel, when they were together, they were moving all horizontal. So it means that they both had a velocity similar to, the parcel have the same velocity as the plane. So meaning the initial velocity of the parcel in the x-axis will actually match the velocity of the plane in the x-axis. So the minute the parcel is dropped from the plane, what is happening is that in the vertical axis, this parcel has no velocity. So in other words, in the vertical axis, the parcel starts with an initial velocity of 0. But in the y-axis, sorry, in the x-axis, the parcel will have the same velocity as the one the plane had. Since, like I explained earlier, the parcel was in the plane, meaning it was moving at the same velocity as the plane. So when the parcel is dropped, it will still have that initial velocity in the horizontal axis, but in the vertical axis, the plane had no velocity, it was moving horizontal, meaning it had 0 velocity in the y-axis. So even the parcel when dropped, the parcel will have 0 velocity in the y-axis. Now, with that in mind, how do we work out this question? Well, in the first part, the question is asking us to find the time taken. So they're saying calculate the time taken between the parcel leaving the airplane and it striking the ground. So in part A, want to find the time it takes from the minute the parcel leaves the plane to the moment it just hits the ground. So there we're going to deal with the vertical axis. In the vertical axis, what we're seeing is that the initial velocity is 0. The final velocity, we don't know what it is, but for now we're not interested in that. But the question tells us a few things here. It says that this plane was flying at a steady speed of 90 meters per second at an altitude of 200 meters. What that is telling us is that this plane was, if that was our plane, then the height from the ground to where this plane is, this height is 200 meters. So for the parcel to fall from the plane and strike the ground, it means that it has to cover this distance coming downwards. So in other words, by the time the parcel strikes the ground, its displacement will be negative 200 meters per second. Sorry, this is displacement, so it is in meters, not per second. So the unit, since this is displacement, is 200 meters. Sorry for that. Okay. Next up, what else do we know? Well, this is in the vertical axis. In the vertical axis, as always, there is acceleration. So the acceleration in the vertical axis is equivalent to gravity, and gravity always moves downwards. So that is negative 9.8 meters per second squared. Okay, what else do we know? This is everything that we're given, and what we want to find is how long it takes the parcel to start with an initial velocity of 0 in the vertical axis and cover a distance or a displacement of minus 200 meters. Okay, so this is what we want to find. So remember what we always say about projectiles. A projectile in the end, even for this particular parcel, because of the presence of this velocity, what the parcel or how the motion of the parcel will be is it will move in this manner until when it strikes the ground. So what we want to find is how long it takes to strike the ground. So let's say this is where the ground is. Okay, so this is where the ground is. So the question is telling us to see that the altitude from there all the way to the bottom is 200 meters. That's the distance, or that's the height. But what we keep on talking about is that the time it takes, if we just assume that this parcel was to fall vertically downwards by looking at only the y component of the velocity, and then the acceleration in the y-axis, and the distance in the y-axis, the time it would take to fall like this will actually predict the total time of flight as the projectile follows its normal trajectory. So by using only the y components, we're getting the time, but that time, what we know is that it's the same time the parcel actually takes when it is moving with both components of its velocity. Okay, with that description, let's see what is happening. So of course, I went in greater details describing these, how we handle these projectiles, including how we handle this case in my introduction video. So again, I'll leave a link so that you guys can just take a look. Okay, so with that, we're just dealing in the y-axis. We already have everything that we're given in the y-axis, the initial velocity in the y-axis, the displacement it falls through in the y-axis, the acceleration in the y-axis, and we're looking for the time it takes to hit the ground. So with that, we see that we've got no use of the final velocity, neither are we interested in it just yet. So we decided to pick an equation that does not use final velocity, not this equation. We're going to use S is equal to ut plus half at squared. With this, the displacement is negative. That's negative 200, is it? Let me just verify that. Yes, that it is. Negative 200. The initial velocity in the y-axis is 0. So when you multiply 0 times the t, we get a 0 here, plus half the acceleration due to gravity, that's negative 9.8. The time is what we're looking for, let's just say t squared. We simplify this, we now have minus 200 is equal to, we have half of negative 9.8, we get negative 4.9, and then here we have t squared. From here, you can quickly notice one thing, the negative and the negative can cancel out, and then if we divide both sides by 4.9, what we'll have is t squared is equal to 200 divided by 4.9. So here you can evaluate the square root. So square root both sides, we get the square root of 200 divided by 4.9. If you do this, you get your value for time as 6.39 seconds. So this becomes the time it takes the parcel to strike the ground. We calculated it in the y-axis, but this doesn't change a thing. The time we find in the y-axis will be the same time it will take to move in the x-axis horizontally, and it will also be the total time of flight for this particular projectile. So this we found it in the y-axis, but again, you're saying it is actually the time it takes the projectile to hit the ground altogether. Okay, so this was the first part. What were we supposed to look for in the second part? So what are they saying? In the second part, they're saying the horizontal distance traveled by the parcel in this time. So for the horizontal distance now, what they're saying is, quite all right, the parcel moves in that manner. That's the trajectory of the parcel. But the horizontal distance is, if we just take it that the parcel is moving from point A in the horizontal axis to point B, what is the distance it will move in the horizontal axis? The distance from point A to point B. So this is what we're looking for. Now, to do this, all we need to find this distance, let's label it as x. So to find this distance, all we need is the speed in the x-axis and the time it takes to move from point A to point B. Now, what you have to keep in mind here is in the x-axis, there is no acceleration. What that means is that the 90 meters per second the parcel had in the horizontal axis immediately when it was released, that 90 meters per second will be maintained throughout. The absence of acceleration in the y-axis, in the x-axis, here implies that the velocity in the x-axis will not change at any point. So it will be maintained throughout until when the parcel hits the ground, 90 meters per second. Even at the bottom, as the parcel hits in the x-axis, it will still have 90 meters per second. Now, this is all because the acceleration in the x-axis is 0. Here, of course, for that condition to work, we are taking it that air resistance here is negligible. That is how we are saying that. That is why we're saying that the velocity will be maintained. Okay, so in the x-axis, the velocity at 90 meters per second is going to be kept constant. With that in mind, we see that in the horizontal axis, the acceleration is 0. The speed or the velocity is maintained at 90 meters per second. Acceleration being 0, we want to find the distance x from point A to point B, given that the total time is still that 6.39 seconds. So again, I'm emphasizing the time it takes the projectile to move from point A to fall vertically downwards to the ground. It will actually be the same time the projectile would take if it moved vertically, horizontally from point A to point B where it strikes the ground. So it will take the same time to move in that direction. But altogether, we know that this projectile moved in this manner and struck the ground at that particular point. So again, if it followed its original path, again, it's the same time it would take. So don't get confused there. In fact, it's the time in the y-axis and the time in the x-axis that actually make this possible. The time it takes to fall vertically downwards is the same as the time it takes to move horizontal from point A to point B. That's the connection between the two axes. So I hope you guys have been able to track that discussion or description. Okay, now we're trying to find what this value x is. So because of the absence of acceleration, now let's say if acceleration is 0 or if velocity is constant throughout, then your go-to equation is the definition of speed. Distance over time. Here we know what the speed is. The speed is that constant 90 meters per second. The distance is what we're looking for. We're calling it x. The time taken here, we calculated it earlier on. It's that 6.39. So if we cross multiply here, we have our expression for x as 90 multiplying 6.39. If we perform the multiplication this time around, we get our distance as 5.7, not 5 point, we get 575.1 meters. So this comes out as our distance. Okay, what was the last part saying? Well, for the last part, they're asking us to find the speed at which the parcel strikes the ground. So they want the speed the parcel strikes the ground with. Now let's quickly just understand what that actually means. So let's say this is our parcel. It moves in this direction and then it comes to strike the ground at that particular point. Now, what you should know here is that there are two velocities the parcel will have as it strikes the ground. One velocity is that 90 meters per second, which is maintained in the horizontal axis, 90 meters per second. But the other velocity will be the downward velocity. The downward velocity it will have. In other words, the final velocity in the y-axis. So let's say v final in the y. So those are the two velocities it will have, but those are components of the main one. What's the main one? Well, the main one is going to be something like that. So that is going to be the main velocity that it will actually hit the ground with. Now, for you to get this question right, there are two methods that you can use to work it out. In one method, you can use linear motion. Since we already know what this velocity is, we can determine what the final velocity in the y-axis will be, then treat these two as components that make this velocity that we are actually looking for. If the question just said the downward velocity the parcel hits the ground with, then they're just looking for the y component, because the y component is the one which is literally just downwards. But here they've just said the velocity the parcel, or the speed the parcel hits the ground with. Because they've just said it like that, they're actually asking for the resultant speed that the parcel hits the ground with, which is this one. Let me label it as just v. So this is v in x, this is v in y, and they're looking for v. So that's what we're trying to determine. So you can determine first vy, since we already have vx, combine them by Pythagoras, then to get what your v is. The second method, which is probably the shorter method to use here, would be the work energy approach. So I will give you that method later on at the very end. But for now, since this is the linear motion playlist, let me just go right ahead and show you this method. Then at the end, I'm going to show you how to use work energy methods to take a shortcut here and just determine straight away what that velocity is. Okay, so how do we do that? Well, in the y-axis, to find Vy, let's look at what is happening in the y-axis. The initial velocity in the y-axis, remember, it's what we had earlier on, it's 0. The displacement we are falling through in the y-axis is negative 200 meters. The acceleration in the y-axis is that negative 9.8 meters per second squared. And we are looking for the final velocity in the y-axis, so V final in the y. We already know the time it takes to hit the ground, so we can also use the time here, would be able to get the correct answer. But even these will be enough for us to get the answer. How does it work? Well, V squared is equal to U squared plus 2AS. Here, since we were looking for V, we can keep it as the subject of the formula. The initial velocity, we're coming from rest, we're coming from 0, so that's 0 plus, then this is 2 multiplying 9.8 negative, multiplying the displacement again negative 200. So if we work this one out, we get V squared is equals to, then we multiply this here. What we're going to have in the end is going to be V squared, the square root, not the square root just yet. So we have, this is going to be positive 2 times 9.8 times 200. And then we get the square root of that. Square root of 2 times 9.8 times 200. If we evaluate this, we're going to get V as 62.6 meters per second. But this is downward. So I can say 62.6 meters downwards, or I can say negative 62.6 meters. This is in the y-axis. That's why I'm saying the velocity it hits the ground within the y-axis. The negative here is just indicating that it's going down. Okay, now what do I mean here? Well, in the x-axis, the velocity was constant throughout. It was always that 90 meters per second, since it was never changing. So to combine these two now to get the final velocity or the speed it actually hits the ground with, first we see that in the x-axis we have this positive 90 meters per second. But in the y-axis we have this downward velocity, which is that 62.6 meters per second. So the final velocity that they're actually looking for is going to be this one here. So we see that to get this value, to get this velocity, we combine these two by Pythagoras theorem. So the longer side is going to be equal to the square root of the two shorter sides squared. This plus negative 62.6 squared. If we work this one out, we're going to get V as 109.6 meters per second, but this is just 110 meters per second. So this becomes the velocity it actually hits the ground with. But this is using linear motion. You saw how we had to do that. We had to first get the final velocity in the y-axis. After that, we had to use Pythagoras theorem to combine the velocity in the y-axis and the velocity in the x-axis. Well, the second method uses energy method, the conservation of energy. How does it work? So this is just going to be a quick demonstration. Perhaps we might look at it again when we start making uploading on Wake Energy. But very quickly, we just look at point, let's say the point where it was dropped from. What forms of energy did it have? Well, at this point, it had PE. PE here was mass times gravity times the height, which was 200 meters. Here I'm using it as a positive. I'm measuring the height relative to where it lands, relative to this point. But it also had kinetic energy since it was moving altogether. You see, energy is a scalar quantity. So there's nothing like X component, Y component. These are just values. So by evaluating the kinetic energy here, I'm just saying half times the mass times the velocity. Regardless of where the velocity is, I'll just use it. The velocity was in the x-axis, but here it's the velocity of the object. So I'll just say 90 squared. But as it lands, where it hits the ground, of course it goes like this, hits the ground somewhere there. But where it lands, what does it have? Well, here since we're saying it is at ground zero, in other words, the height is now zero, implying that it doesn't have potential energy anymore. It only has kinetic energy. And the kinetic energy here will be half times mass times the velocity. So the velocity it hits the ground with is what we're looking for. So if I label this as point A and this as point B, now we see that the energy at A is equal to the energy at B from the conservation of energy. So at A, we have both potential and kinetic. So what we're going to have there is mg 200 plus kinetic energy half m times the 90 squared. This has to be equal to the energy at B, which is just half. And then we have mass times B squared. We're looking for that B squared. Here you see that the mass is going to cancel out. After the mass cancels out, I can multiply through by the 2 there. What I'm going to have is 400 times 9.8. It's 400 because I'm multiplying through by this 2, so that only remains with B squared. So what I'm going to have is here it's 400, 2 times that is 400 times the G, 9.8, plus the 2 is going to cancel with this 2, so it eliminates. I remember it's just 90 squared here. This is what is equal to V squared. Now next up, if I square root, I'm going to have V is equal to the square root of 400 times 9.8 plus 90 squared. This is the square root I'm evaluating. And if you evaluate this, you will see that you directly get 110 meters per second as the velocity it hits the ground with. So I hope you found the energy method a little bit helpful. I feel it is much shorter and straight to the point, unlike the other method where you have to remember to combine your vectors at the end so that you get their resultant. Okay, so this was the energy method. I hope you guys were able to follow through how we calculated this. Remember, we found the time it took the projectile to hit the ground from the y-axis, then we got the horizontal range in the x-axis, and then after that, we got the final velocity the projectile will strike the ground with. Then we also saw how we can get the same value using energy method. In the next video, I think I won't include this one, but I'll leave you guys to try it out. Leave your answers in the chat section, the comment section. Let's see what you guys will find. I'd love to see your answers to this question. So you guys can try out this question. Let's see what you're going to find. Okay, so what is it saying? We have that. Okay, so yeah. All right, you guys, this was your tutor. We'll see you guys in the next tutorial.